integrate 1 over x times x minus 1 quantity cubed using partial fractions. So let's get the partial fractions expression for the integrand. Notice that the bottom has been pre-factored. So we're going to have a x term, we're going to have an x minus 1 term, and then because it's repeated 3 times, an x minus 1 squared and an x minus 1 cubed term. And so each of these contribute one coefficient, a, b, c, d. If we were to put this back on a common denominator of x times x minus 1 cubed, the a term needs the x minus 3 cubed. The b term needs an x and an x minus 1 squared, since it already has an x minus 1. The c term needs an x and an x minus 1. And the d term just needs an x. Since the fractions are the same, we can equate their numerators to get 1 on the far left is equal to a times x minus 1 cubed plus b times x minus 1 squared plus c times x minus 1 plus d on the right. Now we just need to substitute x values. Let's try 0 first. We'd get 1 is equal to a times minus 1 cubed, and then the other terms vanish. That means that a is equal to negative 1, and we can make that replacement here. There's x equals 1 is another good choice. So we'd have 1 is equal to, the first term vanishes, the second term vanishes, the third term vanishes, and we have d times 1. So 1 is equal to d, and there's the second replacement. If we try another value, say 2, we're going to get 1 is equal to a times 1 cubed plus b times 2 times 1 squared plus c times 2 times 1 plus d times 2. If we clean that up, that's 1 is equal to a plus 2b plus 2c plus 2d, and we can make the substitutions. We have 1 is equal to minus 1 plus 2b plus 2c plus 2. Solving this for our guys, we're going to have 2b plus 2c is equal to 0, or b is equal to negative c. One more x value. If we try x equals 3, we're going to have 1 is equal to a times 2 cubed plus b times 3 times 2 squared plus c times 3 times 2 plus d times 3. If we clean this up, that's 1 is equal to 8a plus 12b plus 6c plus 3d. Replacing a and d, we have 1 is equal to negative 8 plus 12b plus 6c plus 3. Or, let's see, cleaning this thing up, we're going to have 12b plus 6c is equal to a grand total of 6. And that means if we divide everything by 6, we have 1 is equal to 2b plus c. Or if you'd like, c is equal to 1 minus 2b. Now we already know what b is from our previous calculation. It's equal to negative c. So this becomes the equation c is equal to 1 plus 2c. That means that c is equal to a grand total of negative 1. And now that we know c, we know b. b is minus minus 1. All the coefficients are found. We can replace b with a 1, c with a minus 1, and we have a partial fractions expansion. Now we can integrate this thing. The integral of 1 over x times x minus 1 cubed dx will be negative 1 times the integral of 1 over x dx plus 1 times the integral of 1 over x minus 1 dx plus negative 1 times 1 over x minus 1 squared dx plus 1 times the integral of 1 over x minus 1 cubed dx. One integral for each coefficient. So let's prep this. We have negative the integral of x to the minus 1 dx plus the integral of x minus 1 to the minus 1 dx minus the integral of x minus 1 to the minus 2 dx plus the integral of x minus 1 to the minus 3 dx. The first integral is easy. That's just negative ln of the absolute value of x dx. All of the other ones we're going to require the same substitution. U equals x minus 1, so we're going to get that du is equal to dx using the usual trick. So the first integral just becomes the integral of u to the minus 1 du. The second is the integral of u to the minus 2 du. The third is the integral of u to the minus 3 du. And so we can integrate each one of these in turn. The first one will give us a natural logarithm, and the other ones will give us power functions. U to the minus 1 times negative, and u to the minus 2 times negative 1/2. If we clean this up and back substitute, we have minus ln of x from the first part, plus ln of the absolute value of x minus 1, minus x minus 1 to the minus 1, minus 1/2 x minus 1 to the minus 2.